It's Tuesday, so your writing assignment is, we know 3 ways to solve a system of equations: graphing, substitution, and elimination. So my question to you is, when is it best to use each one of those methods? When is it best to use graphing? When is it best to use substitution? When is it best to use elimination? If you're watching the video, please pause it now and write. So when is it best to use graphing? If they're given in slope-intercept form. If the equations are already in y equals, why shouldn't you just graph them? Any questions about that? Okay, so when both equations are already given in slope-intercept form, it's best to graph them. Okay, when is it best to use substitution? So when one equation has a variable solved for already, like y equals something or x equals something, and the other one is in maybe standard form, okay? If you only have to solve for one variable, that might be a good way, a good time to use substitution. So if it's like 2x plus y equals 7 or something like that, and you just have to solve for that y, okay, that's a good answer. I'll take that. Anybody else have any other way that you might use substitution when it's best to use substitution? Okay, when either variable has a coefficient of 1. Okay, that's kind of what Joe said, but it just said in a different way. I appreciate that. Okay. So when is it best to use elimination? When 2 of the coefficients have opposite integers. Good. So when they're both in standard form. And what about the coefficients? When everything has a coefficient? Okay. Right. Well, what if they're both in standard form and one has a coefficient of 1? Would you use substitution and would you use elimination? At that point, it's your personal preference, right? If you prefer use substitution or prefer elimination. There are some times when there's a best time to use all 3 of those: graphing, elimination, and substitution, right? It's always possible to use all of them on every problem. There's just maybe not a best way, okay? Are there any questions about that? So that was a whole lesson. Yes, that was a whole lesson. And they gave you, let me find it real quick. They gave you these different, oh, it's not on. They gave you these different, somebody point this at the front. You have to point it at the front to turn it on. They gave you 10 different equations. Okay, they gave you 10 different equations. Thank you, it's on. And you had to decide, okay, is graphing the best? Is substitution the best? Is elimination the best? Okay, so we're just gonna talk really quick because I want you to actually see some examples, and I want you to actually say, make a choice, make a commitment. I would do this one with graphing. I would do this one with substitution, okay? And on some of them, like we talked about just a second ago, on some of them, is there a quote-unquote best way? On some of them, yes, but on all of them, probably not, right? Okay? So, pick one of these that are up here on the screen and tell me, like, which way you would do it. Make a commitment. What do you say, Danny? On A, you would graph it? Would anybody do anything different with A? See, I would use substitution on A. Because I don't want to graph a slope of 26.5 or 36.5. And I don't want to graph a slope of 28.5. And I don't have to plot a y-intercept of 60. So if I know y equals this and y equals this, can't I set them equal to each other and solve? Like substitution? So, but for the record, are these actually in slope-intercept form? Technically, are they? No, that's b plus mx, isn't it? Okay. So, a point of discussion anyway, right? Would Danny get it wrong if he graphed him? No, because probably he would use his calculator and search for the point of intersection and not graph it by hand, right? That would be his argument to what I said. Okay? Kennedy, you had your hand up. Which one would you choose? On F, you would do substitution. Tell me why you would do substitution on F. Very good. Very good. Jesse, what do you got? C, you would use elimination? Tell me why. We already have exactly the same integers, so you just have to multiply one equation by -1 to get opposite integers, don't you? Justin? H, you would use graphing. Because? Both in slope-intercept form. Anybody have a discussion about that? Jordan, what do you choose? D, graphing? Because? Because you can just plug it in. Because it's in slope-intercept form, right? Okay. Anybody else? Danny? G, you would do graphing? So move x over here. And those are real nice numbers for graphing, aren't they? I don't think Justin agrees with you. So you would do G with substitution. See, this is one of those, to me, that's personal preference. You know what I'm saying? To Danny, substitution is more work on this problem. But to you, it's more work to get your calculator out and turn it on and go to graph and put it in and find the intersection. That's a personal preference, isn't it? Are they both going to get the same answer? Yes. Okay. So there's two more on here that you haven't seen, that you can't see, and we've already talked about A and F. How'd you solve E? You would do elimination on E? Can you tell me why? So sometimes you would choose elimination because graphing is going to be very difficult and substitution is going to be very difficult, right? And so sometimes you're left with elimination because that's the one that will create the least amount of work, right? It's not the first one you choose, it's the one you choose because the other two maybe don't work, or you don't feel comfortable with them, or you don't like them. Fair enough? Okay. Solving 3x3 systems of linear equations. They're a little creepy, but that's okay. You guys hang around each other, so you're used to creepiness. You're in the matrix. I don't remember which color of pill you have to choose, okay? Justin, I need you to not talk. Jared, I need you not to talk. And I think that's all I had, right? Just you two? Okay. Especially not yet. I don't want to ruin the surprise. That's tomorrow. Okay? Surprise is tomorrow. Would you hand these out, please? Okay? So, let's look at these faces. What kind of faces do you see? Don't say creepy. Describe them. So we see happy, sad, and indifferent. Okay? Can we make it a little easier than that? And say smiling, frowning, and who cares? Who cares? Okay? So if we have, tell me about this first row right here. If we have 2 smileys and a frowny, whatever that means, that's going to cost $40. What about this one right here? 1 who cares, 2 frownies, whatever that means, is $32. Okay? And you can figure out the other 2, right? So do you know how much a smile is worth? Do you know how much a frown is worth? Do you know how much a who cares is worth? But because we have this set up for us, we can figure that out. Okay? Now, believe me, there are many more meaningful problems that we will get to with systems of equations. We just have to start with a goofy one. Okay? So, first thing we need to do is identify 3 variables in the problem. And to a lot of you, that's going to seem really stupid, because look, there's already 3. Done. Okay? But guys, when it says identify 3 variables, it doesn't just want to know which variables you're using. It wants to know what they mean. Okay? And this is really going to come into play when we start doing problem solving with systems of equations. Like real world problem solving, not like smileys and frownies. Okay? This is just kind of where we're starting. Okay? So, oh no, don't say that. So let's identify 3 variables for this problem. Okay? Let's say that x is going to represent a smile. That's a weird M. Let's say y is going to represent a frown. What's z going to represent? Okay, am I spelling this correctly? Yes. Meh. Okay. For the record, if you check your answers on the answer key, that's going to say who cares, but I'll go with meh. That's fine. Okay? So, we're just going to use the first 3 rows, and we're going to set up 3 equations. Okay? So, what's the first row going to look like? 2x, because there's 2 smiles, plus y, because there's 1 frown, equals 40. Everybody okay with that? Oh, you can't see that. Sorry. Everybody okay with that? Okay, so how are we going to set up row 2? Z plus 2y equals 32. Is everybody all right with that? Okay. What about the third row? X plus 2y equals 35. Which 2 equations contain the same 2 variables? First one and the third one, why do you say that? They both have an x and y. Okay? So what are those equations? Well, let's write them down. 2x plus y equals 40. And x plus 2y equals 35. Okay, so far? Okay. What method can be used to solve this system of 2 equations? Choose one. I mean, oh, so what I'm saying right now is what method can be used? Graphing can be used. Substitution can be used, and elimination, right. Which way should we solve this system? You think elimination? Okay, so we're going to use elimination. So my first question, and the first question I typically get here is, whoa, what happened to the other equation? I'm ignoring it for now. Okay? It's not that I forgot about it. I'm just ignoring it for now. And that's okay. All right? So if I want to solve this system, what is it? 2x plus y equals 40. And x plus 2y equals 35, is that correct? Okay. Which variable should we eliminate? Number 1, doesn't matter. Okay, so we're going to go with x because that's what I heard first. How are we going to eliminate x? If I multiply the whole bottom equation by negative 2, I will get negative 2x minus 4y equals negative 70. Now, I'm going to rewrite this equation here. Why do I want to rewrite it? What do I have lined up if I rewrite it? Everything, right? My x's are lined up, my y's are lined up, and my constants are lined up. And for those of you who are visual learners, you may need those lined up so you can see exactly what's happening. Okay? What's 2x minus 2x? 0. Okay? So that zeroes out. What is y minus 4y? Negative 3y. What is 40 minus 70? Negative 30. If negative 3y equals negative 30, what does y equal? Y equals 10. Yay, there's the answer. What? Oh, we have to find x. Okay. Where do you want to substitute this y back into to find x? You would choose the top one? Why would you choose the top one? You just plug y in right there? For the record, I would choose the bottom one, because x is already by itself. But we'll go with the top one. 2x plus 10 equals 40. 2x equals 30. X equals 15. What? Oh, but do I have to write this as a coordinate? That's a very good question. Isn't this just a smaller part of a bigger system? Yes, so I have to figure out everything now. Use the two values for the variables to solve for the third variable in the remaining equation. Well, my remaining equation is the middle one, right? From here, z plus 2y equals 32. Z plus 2y equals 32. We already know y, right? So z plus 20 equals 32. So z equals 12. So what would be the equation for the fourth row of figures on the front? X plus y plus z equals 37. Plug in the values calculated for the variables into the equation for the fourth row to check your solutions. Well, x is 15, y is 10, z is 12, equals 37. 15 plus 10, 25 plus 12, does 37 equal 37? In my universe, it does. Now answer this question. Which is worth more, a smile or a frown? Well, how much is a smile worth? Smile is worth $15. A frown is worth $10. And a meh is worth $12. Except, remember, you guys are the only one doing this. Okay. So, guess which one's worth the most? A smile. Okay? Is that a surprise? No, it's pretty cheesy, but that's okay. Okay? For some 3x3 systems, substitution does not work. Okay? These 3x3 systems can be solved using combinations or elimination. I think they wanted us to use substitution up here. but you guys wanted to use elimination, so I went with what you wanted. Are you okay with that? Okay. So we're going to look at this example right here. What are the variables in this system? X, Y, and Z. Do they mean anything? At this point, do they mean anything? No. There's not a smile attached to one or a frown. There's not a label attached to any of them. It's just a variable. Are you okay with that? Okay. Select one equation and write it down twice. Well, guess what? They already selected one for you. So basically what we have to do is write it down again. Okay? We're going to place the other two equations below the first one. So I'm going to rewrite this one and write x plus 6y plus 2z equals 3. One of the other equations from the other page is 3x plus 4y minus 3z equals 5. So then I need to rewrite this one, x plus 6y plus 2z equals 3. And one of the other equations from the other side, or excuse me, the other equation from the other side is 6x plus 2y plus 3z equals 4. Now, how random was that? That's fairly random, wasn't it? Some of you guys have problems with that. You want an exact order of stuff to do, and what I just did was pretty random. So let's go over what I just did. I just picked one of these three equations that were on the bottom of the previous page. I just picked one. For whatever reason, they picked the middle one. There doesn't have to be a reason. Okay? We write it down twice. Then we write the other equation with it, just lining it up. Because some of us need that structure. Okay? What we want to do is choose one variable in each one of these two systems and eliminate the same variable from each of the systems. Does that make sense? So if I look at these first two variables and I decide I want to eliminate, which one do you think would be the easiest to eliminate? Z's are already opposite of each other, but they have different coefficients. X's, I would only have to multiply one thing to get rid, like that, just the top equation by -3 to eliminate the x's. The y's I could eliminate easily because they're both dividing into 12, right? But I'd have to multiply the top by 2 and the bottom by -3. So which one do you think we ought to do? Maybe x? Is that okay with everyone? Okay? So if we eliminate the x here, when I start on this system, I also have to eliminate the x. Okay? So I'm separating this system into two separate systems, and I'm eliminating the x both times. Are you clear about that? Okay, so let's eliminate the x. How am I going to eliminate the x here? Multiply the top one by -3. When I multiply the top one by -3, I get -3x. I get -18y. I get -6z. And I get -9. Correct? Okay, then I'm going to rewrite my second equation. What am I going to do? Combine them. -3x plus 3x, 0. -18y plus 4y, -14y, -6z and -3z, -9z equals -4. So what have I done? Eliminated the x. Okay, so far? Now I'm going to stop and I'm going to ignore that for just a second. I'm going to go to the other one and I'm going to eliminate the x. Okay, so I'm going to multiply the top equation by -6. So I get -6x minus 36y minus 12z equals negative 18. I'm going to rewrite my second equation because I don't need to do anything to that to be able to eliminate my x. And then I'm going to combine. What do I get when I combine? Negative 6x and 6x, 0. Negative 36y plus 2y, negative 34y. Negative 12z plus 3z, negative 9z. Negative 18 and 4, negative 14. Okay? Now what do I have? I have two equations with two variables. So basically what I've done is I've created myself a new system with two equations and two variables. Okay? If I have two equations and two variables, is that enough to solve for each of the variables? What happens if I have 5 equations? How many variables are there going to be in there? Probably 5. Or maybe a better way to think of it, if I have 5 variables, how many equations do I need to solve for all of them? 5. If I have 3 variables, I need 3 equations. If I have 17 variables, I need 17 equations. I don't want to go there. Neither do you. So let's just stay with these. Okay? So now I'm going to collect the remaining 2 equations. Collect them, which means write them again. Negative 14y minus 9z equals negative 4. And negative 34y minus 9z equals negative 14. Now, one of you a second ago noticed the fact that I have now the exact same z's, don't I? Is that what I need? What do I need? I need opposite z's. Well, that's pretty simple in a problem like this. Because if I multiply this entire equation, either one of them, right, top or bottom, by negative, won't that give me what I need? Which one do you want to multiply, top or bottom, by the negative 1? Bottom by negative 1, so I get negative 14y minus 9z equals negative 4. Okay, some of you are looking at my z's like they're funny, and I don't care. But I put a line through my z's so you know which ones are my z's and which ones are my 2's, because sometimes I get so excited when I'm working systems of equations and you can't tell the difference between my 2's and my z's. Just so you know. Okay? So if I'm multiplying this entire equation by negative 1, I get 34y plus 9z equals 14. Now watch what happens when I combine them. What do I get? 20y, that is 0, equals 10. OMG. What's y? A half? Or 0.5, right? If I know what y is, can I find z? How? Where? Plug it in where? One of what equations? Like way back up here? How about if I plug it into one of these? If I plug y in here, won't I find z? Okay, which one do you want to use? Oh, you want to use this one right here? We can use that one, that's fine. 34y, oh, I know what y is. Times a half. Plus 9z equals 14. What's half of 34? 17 plus 9z equals 14. And if I subtract 17 from both sides, I get 9z equals negative 3. What's z equal? And now if I know y and I know z, can I find x? How? Back to the original equations, like from the front of this page. Which one would you choose? Why would we choose the middle one? X is already solved for. It's already by itself. Okay? So x plus 6 times y, which was a half, plus 2 times Negative 1/3 equals 3. Okay. So what's half of 6? And what's a negative third of 2? How about negative 2/3? Right? Equals 3. What's 3 and negative 2/3? X plus 2 1/3 equals 3. And how do I solve for x? Subtract 2 1/3. What's x equal? 2/3? Don't you just love fractions? Write the final answer in point form. What kind of point is this called? It's not an ordered pair. Ordered triple. Okay? What's the answer? 2/3. Wait, why is 2/3 first? Because it's x. And then 1/2 because it's y. Done. And then it says, and check the solution in all equations. It has this tiny, tiny little box. Great, thanks a lot. I want you to at least check them in your brain. Okay? Questions? You have 1 through 4. That is all. 1 through 4. And for the record, only one of them has answers that are fractions. Okay? Only one of them has answers that are fractions. The other 3 have answers that are integers. And I'm not going to tell you that it's number 4 that has that has fractions, but just know that one of them has fractions as answers. I know. Any questions?